All right, what's up? I'm Alex Entrepreneur. I'm here, and today I'm doing a code review of the Badger DAO code. Um, Badger DAO is a DeFi protocol that aims to bring yield to Bitcoin. So let me close that. I'm gonna start sharing my screen. You can check Badger DAO at badger.finance. And I'm in the process of writing what is called a brownie mix, which is basically a brownie, which is a Python package that allows you to write smart contracts, test them, and deploy them. And so since I'm going through all this code, I basically have to figure out how the Badger system tests are done. And so I thought it would be a good idea to just record that so I can vocalize my thoughts and share them and hopefully do something that is helpful to you as well. Anyway, you can check Badger.finance at app.badger.finance. They have they used to have 600 million, now it's 500 million because it's mostly Bitcoin, so it oscillates with the price of BTC fairly closely. That said, I'm going in the Badger Finance Badger System repo. And fundamentally, the architecture that Badger uses is based on Yearn v1, which means that we're going to have a vault, we're going to have a controller, and we're going to have strategies. And for each vault, only one strategy can be active at a time, which is the classic Yearn v1 style. And also we have the controller, which is basically more work for the developer. It's basically not a code, but that's current And I'm going to very briefly go over these. My goal is to go over the actual Python code more so than the Solidity code. If you watch my Yearn v1 video, you'll see that they're fairly similar. The main difference is we have a pausable, a gradable, which come from Open Zeppelin. And then there's some nice to-haves that they also have. You have to call initialize to initialize a contract when it's upgradable. Otherwise, you would just call it in the constructor. And fundamentally, you have these basic view functions to get some basic information, price per share, which is basically the way to determine what a share is worth. And then balance to get the current balance, which is added between the balance of this contract as well as the balance of the controller. Set the controller and the strategy. And I believe that the strategy balance is probably added in the controller. So that's how the entire thing works. Notice that this is not accounting for rewards, LP shares, or anything else. So the implementation of the strategy level may be critical. Available is probably just the one that is floating. Then we have a function deposit. We have this interesting modifier called block locked, which basically means that you can only interact with the contract once per block. And that's a great idea to avoid reentrancy and most importantly, to avoid flash loan attacks. I think that's a great idea. Lock for block, block locked. Okay. And then we have deposit, withdraw, all these nice functions. We also have a guest list. That's something to keep in mind, that sets use guest list, which means that not everybody can deposit. And then we have our harvest function, which basically we'll just call. Actually, in this case, just transfer the funds from the controller. No, it just sends the funds from the set to the controller. Then we have a function called earn, which basically calls earn on the controller, very similar to Yearn v1. And then we have this weird deposit math, which again is done in this way because we have to deal with the controller and stuff like that. Otherwise, you could write a cleaner, simpler set of functions. Same goes for the withdraw. The one optimization here, this is literally the same code that you will see on your V1. And the one optimization that you have is that they try to avoid withdrawing here by checking for balance of token. And obviously, if you don't have enough, then you do have to withdraw, which means that it's going to be more gas expensive. But yeah, this is basically a Yearn V1 controller with nice to haves. Then we have a controller, which fundamentally will just check what the basically manage the vault. And then we have the earn function, which will check for converters, which is a way to swap into tokens, and then do basically fill up the strategy with all the funds, and then call deposit on a strategy, which is the way in which the strategy levers up or basically invests. And what a strategy does, I think I also have a chart on that. But fundamentally, what a strategy does, and it can do more things than this, but fundamentally at a high level, what a strategy needs to do is deposit, which means that it will invest the amount of want received. Then it also needs to create this withdraw sum function that basically allows to liquidate, where liquidate means converting whatever into the want, the token that the user wants to retrieve. And then there's a harvest function that allows to earn. Basically, that's the earn function, harvest, etc. They're interchangeable. At this point, you always call them harvest. And harvest means take the rewards, convert them to whatever, and report the harvest. And that's the function you want to really take care of. And then you have a couple more ideas or functions called tend and is tendable, which not always are necessary. So if you're doing like a super basic strat, let's say you're going on compound, and all you're doing, which by the way, if you ever want to go on compound and deposit, this is the free alpha of the show. If you ever want to just deposit on compound, let's say you want to deposit DAI and you want to get 4% on your DAI, you would actually be better off just going on idle.finance and deposit the same DAI on idle, because they will deposit to compound and then do some extra stuff and also give you their idle token. And that's why, in a way, you then the next level will be to go to harvest of finance, which is basically taking idle and taking compound and reinvesting it all. And so at that point, you will be like, well, I may as well just invest in Yearn of finance, because if I'm going to invest my DAI and I know that my DAI is going to go here anyway, I may as well get the rewards from idle and the rewards from harvest on Yearn of finance. So it's kind of funny, but that's basically the reasoning. And obviously you do get added layers of risk. The more risk you get, or the more layers you go through. But that said, these are fairly battle tested protocols at this point. They've survived over a year with over $100 million. In this case, 246, which is insane if you think about it. And then Harvest, I think, has like 600 million, something really high. And Yearn has like 4.8 billion at this point. So, you can, if you're gonna put your money in DeFi, you can trust one of these. Compound is like 10 billion, etc. But fundamentally, that's the entire idea. So given that, the challenge is not really in writing the code, although there is some technical challenges and you can make a lot of mistakes, but the real challenge is writing tests. And that's what my goal for this call is, for this video. So I got the Badger system and actually downloaded it here on Badger system. And so what I'm gonna do in this video is I'm gonna go through every single file on the test folder, because I need to figure that out. And I'll also just vocalize that. So if you are trying to contribute to Badger, this may be the only video you'll find. There seems to be some documentation on Badger DAO, Badger DAO Gitbook, Badger-Finance Gitbook.io, and fundamentally talks about the testing framework here. And if you already know how the entire flow is going to work, then this is enough. but from my experience, you have to use the code before you can understand even what the notes here say. But I guess I'll go through this docs just to give context to the viewer and to give context to myself. So all V1 strategy implement common externally facing actions. As we said, we have deposit, withdraw, earn, harvest, and earn is optional. And then to test these actions and ensure expected state changes, there is a common framework centered around the snapshot manager and the strategy resolver classes. The framework provided is designed to provide a solid, consistent, and extensible base for testing strategies. So let's check what this snapshot manager is. And whenever you search for classes in Python, just put class at the beginning and you'll find it in a second. So this is the snapshot manager. We see that it has a bunch of keys: set, strategy, controller, want, resolver, snaps, etc. And from what I already know, I know that the snaps are stuff that basically that tracks funds, while everything else sounds really familiar if you ever developed a farm, basically. So set is the vault, strategy is the strategy, controller is the controller, want is the token that the strategy wants. And then resolver, we'll have to figure out what that is. But resolver, at least from checking the source code, it makes me think about something that basically gives me either more information, such as all the configuration, or perhaps the address or the contract or stuff like that. Then we see add snap calls, snap, which is something you'll see a lot. And then we have, I believe, we have a bunch of stuff here, but then we have diff, which is, you know, just a difference. I think there's a function called compare. Let me see, because I wrote it the other day. Snap, 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 snap. There we go. Diff last chew. So diff last chew, given the snap, you have diff last chew, and diff last chew will basically give you the difference between the chew codes or the chew balances. So it's really good. It's a really good tool. But that said, we have this snapshot manager, and in a way, we are basically taking a lot of code for fundamentally what is the idea of just checking the balance before, checking the balance after. So it's just a good idea to think whether we actually need it or not, you know, whether we want to pour that. So, but that's basically what the snapshot manager is. So it may also be a good idea to add some sort of comments here. Let me see which branch I'm in. Okay, maybe I'll just write myself some notes here. Track specific token balances and compare them. Use snapshot manager .snap to, and I guess I'll just open a Notion because that way it's a remote file we can all have. Class that allow to track specific token balance and compare them across time. Use snapshot manager.snap to take a snap of the current state. Use, what was it called? Diff last chew. Yeah. Use snapshot manager dot diff last chew to compare between chew snaps. Okay. So that's the snapshot manager. And I think that we may also want to check how it's configured. So let's just quickly find, I remember seeing something, add snap calls, blah, 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 add entity. Get token balances. Balance the snapshot, that's how you set it up. So let's just take a screenshot of this, I guess. initialize with tokens and addresses to track. Let's do a code here. There we go. So snapshot equal blah, 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 where these are the tokens and these are the addresses. All right. So, and as you can see, taking notes takes some time, but it actually will save you a lot of time in the long run. So it's just a good practice to just be patient and do this. Then we have the strategy resolver classes. So I guess we'll figure out what that is. Let's just search for it. Again, class strategy resolver. Maybe I'll zoom in a little bit so you can see it a little bit better. So it seems like there is no strategy resolver. Strategy Badger rewards resolver. Let's see. Class blah blah blah. Strategy core resolver. So let's see what that is. Class strategy core resolver. Strategy core resolver. Add entity shares for token. Add entity balance for token. Add balances snap. Add set to snap. Calls.append. Add strategies snap. I'm honestly not sure what this does, but it seems to be a way to group other functionality. What is call? I guess let's figure that out. Call from multi-call. So it's basically a way to make multiple calls to the network and basically run multiple transactions. And then it just does stuff. Add entity shares for token. So I'm guessing it will create, in this case, it's func.dig.shares of entity on token address. Shares token key entity as way. I think it's some sort of way to save time where basically set up a bunch of automated functions, but I don't really see how you will use it. So I guess a good idea would be to find something that is similar, you know, something like Snap, which we already found. So maybe we'll find and use a usage that, you know, can explain what's going on, or at least give me a little bit more clarity. Add snap calls, add set snap, and we see that it's calling the resolver, which is the previous keyword for the snapshot manager. So it seems like the snapshot manager uses the resolver to do a bunch of stuff. And I'm guessing that has to do with these new functions here, perhaps. No, it doesn't. These functions here seems to be just shortcuts where you make it do something like Badger dot call the manager and call tend on the manager, and then snap and snap, which basically means track the before and after. So this are basically just shortcuts, just you know, utility functions. So anyway, we'll see whether this becomes relevant. But that said, we do know what the snapshot manager is. So tracking state and changes and verifying results. The snapshot manager class wraps a strategy and associated set with convenience function for taking snapshots of strategy state, comparing state before and after actions, and printing state. I'm sure there's a better name for this structure. Oh, that's okay. Each core strategy action has a wrapped function here that compares state before and after the action. So these are the add snap call, set tend via manager, set harvest via manager, set harvest, etc. Basically the function that do basically the shortcuts that call snap on it. So that's cool. There's a series of strategy resolvers that define what properties to track on state snapshots to load through before and after the function call. The strategy resolver defines a set of conditions common to all V1 strategies. Child classes for an strategy, such as strategy harvest, meta farm resolver, implement additional tracked state and expected conditions on top of the core class. State snapshots are taken using multi-call and end up with the dict with key value pairs. The snap class provides a wrap around the snapshot dict and gives more convenience access to the underlying data. Examples of this functionality, and this is where the fun begins, can be found in strategy file. This runs through basic integration tests of strategies, verifying expected state after each step. So let's enter this file in the test. Test strategy. There we go. At this point, we're searching for core result. Find it. It's hidden behind this manager. So we see the manager here, and I guess we'll read this entire bit of it, and it may be a good idea to exactly know what that is. So test user harvest, test deposit withdraw single user flow. Test deposit withdraw single user flow. So we obviously expect this to have to deal with depositing and withdrawing. And if you know the architecture, you can only deposit and withdraw to a set, which is a vault, and then the controller take care of depositing to the strategy. You never interact with the strategy directly. You never interact with the controller directly. The only thing you can interact with is the set, the vault. Everything else is you're blacklisted. You can't interact. Otherwise, we have multiple security vulnerabilities. So Badger single set basically is a way to fetch the Badger, which is no Badger single set given the set config. Badger.get set. So basically this will get this Badger object, which is something that we'll definitely encounter as we continue working here. Then we have set equals Badger.get set given set config ID. So basically we'll get the specific set. And if you notice, set config is here and it's basically parameterized, which means that given this name set config here, what Python will do is we'll take this object called set test config and it will iterate over every key. And it will basically run this test once per key by passing the value of the key. So basically you will have config 0, and then it will just take this and put it here. That's basically what will happen. And so that's how you want to think about these tests, is that they are templates for multiple types of inputs. So anyway, we're going to get the set, we get the strategy, we never use it. We get the want, we get the deployer. Set keeper basically finds account at set.keeper. It basically connects to an account. Force true means it's mine. For testing purposes, I will own the account and do whatever I want with it. But fundamentally, we get the keeper, which is a trusted account that can do stuff. That's as far as we know. So now we got snap equals snapshot manager, random user equals account 6. So literally just an account. And then it's going to print out what we're about to do. It's going to assert that the deployer has more than 0 balance of want. So they need to have some funds. This is where my personal experience working with this, I had some challenges with this, because the thing we could do to improve this is to, and I'll put it here as a personal note, but basically we could check for balance and mint tokens for deployer, because otherwise you're going to get asserts that fail because you just didn't set it up, which means that this test is not an independent test, which may create some other issues later, especially because this is being parameterized. So you basically will want deployer to have the tokens before the test starts, which if you don't have a way to give them the tokens, it basically breaks the test automatically. But that said, deposit amount is going to be the balance of the deployer, 80% of the balance, and we need it to be greater than 0, which is basically the same check as here. Then we're going to approve it. You need to approve before you can deposit. And then it's going to do snap.set deposit. So let's go into snapshot manager, see what set deposit is. Whoops. And there we go. Set deposit basically overrides from address. User equal overrides dot from address. Okay, so basically overrides it to be from the deployer, and that's the user. Then he checks tracked user, and then he just does a snap and then it deposits in the set by calling set.deposit, and then it snaps again. And then it confirm resolver.confirm deposit, blah, blah, blah. So I'm guessing that resolver.confirm deposit, which is here, is the internal test, is basically a check that verifies that this is working as intended. So let's see if that's the case. Confirm deposit. Deposit should increase the total supply, increase the balance of set tokens for the user based on deposit divided by price per share, increase the balance of in set by deposit amount, decrease the balance of want of the user by deposit amount. Let's see if that's the case. Before get, I'm guessing before and after is basically a way to get insight into the snapshots. I'm not sure where before comes. Before comes from confirm deposit. Did we even get that? Before and after? Oh, okay, there we go. So basically before is the after effect of self.snap, which we assume is literally an object that represents all of the balances that are being snapped. So this idea of snapshots, which sounds so complicated, at the end of the day, it's just an object with keys and probably pairs, address, and then list of every token that is being tracked, and then the balance. Even though I have never seen the data structure, that's the idea I'm having, because it just makes sense as how you will structure it. So fundamentally, that's the the pre, the after, and then the checks to the specifics check that we need to run. And obviously, this confirm deposit is customized so that it needs to run those checks that are specific. So yeah, I mean, this is not a generic test. This is a test that can only pass for the sets that we are using, with the setup that we have, with the math that we use. So very briefly, expected shares, it's just PPFS is probably the price per full share. Okay. And then we get the amount multiplied by 1 ether, because we have 18 decimals per set per share basically, and then he basically verifies that that's it. Assert approx, I'm guessing approx is a utility. Helper.utils, so we'll just check what approx is, but fundamentally it probably allows for some level of mistake. Helpers.utils, so it's gonna be helpers utils approx. Diff is 0, return true. If diff is less than percentile threshold, then that's okay. Okay. So fundamentally, it just verifies that the deposit does work. So from my point of view, this thing right here is basically an entire test, because this is using the strategy core resolver from the snapshot manager to run, what was it, deposit. To run confirm deposit to verify that the deposit actually works. So this line right here has a lot of meaning. So this is probably something I need to remember. But basically all the strategy core resolvers, they have implicit tests that are based on the base strategy. So what this means is that when you're testing any strategy, you're basically testing it against the base strategy implicitly, which means that we may not even have a set of tests on the base strategy, because every strategy is a base strategy. So the way this was done is to basically test at every level, in a sense, test every time, versus just testing the base strategy and then testing the specifics of the different strategy. Anyhow, the next step of the strategy flow is to check that earn called by a random user reverts. So this is a permission check. Then min equals set min, max equals set max. It's going to call set earn from the keeper. It's going to let the chain slip. It's going to mine a block, and then it's going to call set withdraw. deposit amount, it's going to divide, I think this is the integer division. I'm actually not sure. Floor division, true division versus floor division. Okay, so that's the floor division, which is which means that you know, I'm getting super nerdy here, but I think you don't need to do -1 if you're gonna do the floor division, because it's already the floor division. But and maybe if you do this, you are guaranteed to remain with one way of asset, but it doesn't matter, honestly. Anyway, we're gonna withdraw, and then we're gonna withdraw again. So, and again, we're calling, because that's the thing that we want to remember, is that these functions here, they are tests. That's the difficult thing to wrap around. So I'm gonna go in the snapshot manager, and there's gonna be set earn, which is gonna do a bunch of stuff, and then it's gonna call confirm or earn on the resolver, right? Which is tests. These are all tests that are you don't think about them as tests, but they are. So what this means is that every time we see this in this function, those are all tests that are happening. Set earn, set withdraw, set withdraw. So this means that it may be a good idea to go over all tests, delete all code except snap.set XYZ, and then port those to the Brownie mix. Because my goal is to find the smallest amount of tests, yet fewest amount of tests that we can have, so that the entire thing works, right? So that we can have a Brownie mix with one file called the strategy, so that you can write your strategy, and you know, you don't have to think about these millions of lines of code that I've never seen. You can just write 20 lines of code. As long as they produce yield and they work, we can then just press a button, deploy them on a test net, deploy them on mainnet, run it for a week, and then we can run the integration test in the monorepo, which you know, requires just a higher level of sophistication that we shouldn't require out of a random contributor, you know. So let's continue checking this out. This was actually really a great idea. So my advice is if you're learning the Badger stack, to really start from here and then compare with the source code, because it really helped me, you know. So let's continue. There are a series of strategy resolvers. We did that. The test strategy flow is obviously very important, but it's not the test strategy flow in itself. Is the fact that the test strategy flow is using the snapshot manager as well as the strategy core resolver to run tests that you don't see. So all of these are basically test, and you don't see them. So that's cool on an engineering level, but it's also means that you have to keep track of that. Let's continue. To test access control, we can check the test strategy permissions. This is not yet designed to seamlessly allow extension to new strategy-specific access control functions. For the meantime, this test should be implemented in separate files. So let's check test strategy permissions.py. Test strategy permissions.py. Okay. So we see this state setup function that will set up a bunch of stuff. Again, anytime we see the snap, we want to think that there are tests that are implicit, but this actually looks to be a normal set of tests. So basically we have this state setup, controller gets the controller ID. Again, set ID and set config are parameterized, which means that anytime you basically get this object representing all of the stats, all of the setup. Then we have Badger gets set ID, strategy Badger gets strategy set ID. Basically, we get all the configuration, same here, strategy keeper, tendable, blah, blah, blah. Starting balance, want the balance of deployer, we get 80% to deposit. We assert that starting balance is greater than equal than deposit amount, so that you're depositing less than everything. Then want.approve, we basically approve, we basically deploy, we wait for 1 day, we mine the chain, and then we call earn. And you have to wait some time before you can call earn. That's the beauty of doing a fork net test, is that every other protocol will still run, quote unquote. The simulation will continue to run, which means that we can actually earn without, having to write hundreds of mocks. Then we make it slip, we mine, we check if it's tendable, strategy.tend, although tendable was asked here, so it may be a good idea to check it here after this stuff happened, because technically that tendable could change to something else. And then harvest, then we call harvest to harvest our rewards. And then accounts at, you basically set these accounts dot@. I'm actually not sure what this does, so I guess I'll check the Brownie docs. Accounts at address force. Given an address as a string, returns the corresponding account or local account from the container. If force through, returns and adds the account even if it's not found in the container. Use this if an account is unlocked by external means. So you will get back the account object. What I'm not sure about is why it's not attached to anything, right? It's not assigned to anything. So they basically unlock these wallets, but they don't do anything. We'll see. So anyway, this is the strategy action permission. So basically, we're going to test the strategy. Tendable, we check if the strategy is tendable, which is a public function. Anybody can see it. We get a random user. We called the authorized actor equals to strategy.governance, strategy.keepers. Actor, authorized actors. So I'm guessing doing this unlocks the wallets and it allows you to then do actor in authorized actors from actor here. And basically the wallet now works. While if you don't call accounts at, the wallet is not unlocked. So you can't call a function from a random account. So I guess that's a way to use an address that you don't know. So that's a cool idea. Maybe I'll have to use it later as well. Anyway, actor in authorized actor, deposit from actor. Then we're going to check that Brindar reverts only authorized actor. So this is checking that the next line will revert with this error message. And we're trying to harvest from a random user. That's not allowed. That's illegal. So you can't do it. Then we have actor in authorized actors, harvest from actor. So that's cool. If it's tendable, we only let you tend from the authorized actor. That's cool. And then we have actors to check. Again, this has to revert. Only the controller can withdraw all. So if any random actor, whoever, even a trust, even the governance, try to withdraw from the strategy, they're not going to let it do it because the only entity that can withdraw from the strategy is the controller. That's really important. So I for sure will have to use this thing in the Brownie mix, because if you don't get that right, you basically are your strategy is absolutely vulnerable to a million types of attacks, and it's not even an attack at that point. It's barely social engineering. So anyway, Brownie reverts only controller, blah blah blah. Okay, so I think that gives me an intuition as to how the tests are done, and actually reading the code and reading the docs actually helps. I didn't expect it to be that helpful, but it was a great idea. So now let's check adding a new strategy. The test conf.test.py file holds setup logic for most tests. Setup for most tests. The core flow and permission tests are parameterized to run their test for a series of keys, which map to setup conditions, sets to run, blah, blah, blah. These tests use the Badger single set function to grab the setup, which results in a Badger system that contains all the contracts for use in the test. So there's multiple layers here. Let's go in the conf.test.py file. So we're in tests/conf tests.py, right? And we have the sets to run, this image right here. We then check the Badger single set. Badger single set with the set config, which again is going to get injected after the Badger single. Set config, where an ID is basically done in this way, where you have the name of the controller and then the name of the which is a great convention, really convenient. Anyway, given that if the mode is test and then the set ID is whatever, then we're going to return this mini deploy, which let's see if we can get some insight into. So the default sets all define a minimal Badger system for the individual set plus strategy being tested. These expand upon the set mini deploy base class. This may involve deploying the set, deploying the support infrastructure, and transferring the test asset to the test account. Okay, to add a testing environment of a new strategy, add a new key to the Badger single set function and the associated test environment setup. So test environment setup at this point corresponds to the keyword set mini deploy base. So let's go ahead and search for that. So this is the Badger rewards mini deploy, but we are looking for the set mini deploy base. Okay, so we have the set mini deploy base. The initialization, we receive a key, a strategy name, deployer, strategy governance, keeper, and guardian. Basically the basic setup. I'm not seeing any controller here. I'm guessing because there's a default controller. Yeah, controller self.key. Basically the controller is here. So anyway, what's happening? If there's no strategies, then the strategy becomes the deployer. If there's no governance, the governance is the deployer, blah, blah, blah. Basically message.sender becomes all of this stuff. That's cool. Self.strategies, blah, blah, blah. Def deploy, the function deploy will return a Badger system, which I guess we'll check really quickly. A Badger system, strategy artifact logic set system. It basically seems to be this object with all of the configuration, but we're returning it in the mini version because we're doing this mini deploy. So let's see, self.badger is connect badger, and connect badger basically just returns you an object that allows you to sign transactions. Blah, 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 connect badger, connect logic. It basically returns all of the logic connected, connect treasury, connect multisig. Then self.predeploy setup Pre-deploy, in this case, there's nothing, but I do believe that a separate strat will define pre-deploy. So if I go in the specific strat called Badger Rewards Mini, the pre-deploy is setting self.rewards equal to self.badger.deploy set staking rewards, which means that it's setting up a separate thingy. So let's read this over. Deploy, distribute test ether just to pay for the gas. Controller, it gets the controller from the set system, and then it sets the vault, badger.setSystem.vaults, and then post vault deploy setup. Strategy is basically the strategy with this key, which again comes from set system. And then post deploy setup just calls post deploy setup, which again we'll see an implementation in some of the mini deploys. In this case, it just called distribute and grant role to the self-loss strategy. Okay, it basically runs as something that you can customize. So like in a perfect world, we would basically take this deploy function, put it in the Badger mix, and that will be the way to have the entire thing wired and ready. And then the only thing left will be to just write the tests, which we saw that there's 2 files that basically already do that. So that will be the perfect world setup, where these monorepo is a package, something like an npm package or a Python package that we can just install, and it allows us to retrieve those configs. And given those configs, we can just use them basically. So that may be the better way, or the easiest way, but we'll have to see what we can actually do. So I guess I'll finish reading this, and then we'll see. Blah, 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 to add a new, blah, blah, blah. Let's see, adding a new strategy. When testing strategies, snapshots are taken of state before and after, and results are compared to expectations. This happens via snapshot manager and resolver class. Resolvers are strategy-specific helper class that define what properties to track in snapshots and how to verify the result of actions. Deposit, withdraw, blah, blah, blah. In terms of our value, works are expected to change. In addition, strategies are unit tested using fresh, minimal deployments of the relevant components. This allows them to be tested in isolation and speeds up runtime by deploying less contracts. This process is managed via helper classes called mini deploys. These define the minimum setup for all strategy, or for a strategy. All classes extend from in deploy based contract. Yeah. Yeah, and then you have a little bit of documentation on this, so this is cool. I would say the big question at this point is what can be deleted, because clearly there is a a grand vision. There is like this was done in a certain way, right? You have the Badger system, you have the snapshot manager, you have the registry resolver that implicitly runs tests. So you do have an architecture that is defined. It's a well-defined architecture. That well-defined architecture implies that anytime you want to test a new strat, you will need to create a new mini deployment. Right? So basically, you will need to create a file such as these that basically fetches params, which I believe is really similar to for everyone. Then you have the post-deploy setup. Then you have the pre-deploy setup. And then you have to just wire that up in the conf test so that it returns here given the specific key. And then every test in the monorepo will run against it, or at least any test that is already wired up, which I believe currently are the test simulation, test strategy flow, test strategy permissions. Yeah, so all of these will run against it basically. And maybe even just maybe even more. Now this is based on time lock. I mean, the big question we're left with is whether these tests are testing everything, which I don't believe they are. I believe there's some stuff that is not being tested. And whether that's done on design or whether we should fix that. And then the other thing is, I guess I would love to see an actual example. And if I'm not mistaken, I did a code review of work submitted by Mushroom Finance. So let's see if we have the pull request from Mushroom. I think it was REM-BTC. Core strategy, Mushroom REM-BTC strat with unit protocol. So I'm familiar with how the strategy works. And basically it provides REM-BTC to the unit protocol to mint USDP. And then it provides the USDP on Curve to earn trading fees and Curve. So that's how the strategy works. So I guess what we can check is what they did to add the test so that I have a reference of something that I've also already worked with. And maybe I even have the code. No. So, well, I guess I'll just do it this way. But there is a command that allows you to fetch from any pull request. It's I have it in my copy paste stuff. Stabilize, blah blah blah. Stabilize. I think this is just the linter. Protocol meta. Yeah, this is what they write, which is the reusable part of the strategy. And again, it just takes, it goes on unit protocol, takes USDP and provides it to Curve. That's the goal. Multi-goal functions.py, unit protocol, collaterals, get collateral, that's USDP of pool. So there is this setup of multi-goal functions.py. Then there's chain registry, which I think just sets up, let's actually check that out on the helpers registry. Helpers multi-goal registry. Helpers registry chain link. Okay, one more. Chain registry. Blah, 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 blah. Do we have chain link? We don't, because this is not merged. But fundamentally, this is just getting the various setups. Yeah. Scripts.system.token system. Let's check that out of curiosity. Scripts, systems, token, system. ERC by key, ERC by address, and then it returns the token. Okay. Okay, then it sets up if registry with the addresses. And if registry, basically the mainnet registry, which contains all of these mapping of addresses. Then we have the, let's see, again, same thing, more addresses. Registry, just adds it here. And then it does the strategy unit protocol REM-BTC resolver to find the resolver for the snapshot manager. So let's check what the resolver looks like. And I'll open that up and I'll check it out in a minute. And then we have init.py, which basically just imports it. And then again, more wiring. Then we have the Chainlink interface, more linting, more linting. the unit protocol code, which is again interfaces. And then we have the set system, which is now set up to do the mini deployment, I guess, right? In this case, it's actually calling deploy proxy, blah, 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 governance, blah, blah, blah. Okay. Actually, they're all calling deploy proxy, so I think that's fine. I guess I'll check this out as well. And then we have the mini deployment finally, and this is the mini deployment. So I guess we'll check that out as well. And lastly, we have the test with test strategy flow unit RAMBTC, where it still used the parameterize, even though the test is set up for one test, or I guess they just copied the test actually. And they added the distribute from Wales because otherwise you fail. It fails, I guess. Although maybe I missed it. Let me see. Maybe it was actually already there. Distribute from Wales. No, they added it because it fails if you don't do it. It always fails basically, unless you have an address with a ton of stuff already there. And beside that, it basically runs a bunch of checks and it checks a bunch of stuff, which is cool. And it does it with snap. And then it asserts here. So the stuff that you don't snap, it asserts. Although we could argue that the tests that require snapping are already done in the integration. So the only tests that you will truly need to write are the ones that are not run in the original function called testing all user harvest flow, because any strategy you submit with a mini deployment will automatically run through these. So what you would have to add is the stuff that you didn't, that is not checked. So perhaps, you know, the gauge logic, the curve logic, the USDP logic, that stuff. Okay, so let's just dig a little deeper before saying we understood it. Strategy unit protocol RAMBTC resolver.py. Basically, add balance to snap, add strategy snap, confirm harvest event, print harvest state, confirm harvest, confirm tend, etc. So basically, this is the you know, the implicit tests. Confirm harvest event, which doesn't seem to actually test. This one is asserting though, so this is good. Confirm tend, etc. Okay, so let me store this example of a resolver. Then we have the set system.py, which is basically used to deploy. So we're searching for the RAMBTC, which is this one, deploy proxy, blah, 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 with the setup, which apparently is always the same. Yeah, apparently is always done this way. Params. Params, which come from here, from deploy strategy. Okay. Example of deployment in tool. Hey Diogo, good to see you, man. Hope you enjoy your time here, man. So then you have the fixture tool. And I guess that's basically it. So we basically covered, and I do have a call in a few minutes relating to this, but fundamentally we did cover the basics of how the entire thing is built. I don't know if I could build it better, to be honest. I think it's actually really well thought out. The downside that I do see are the implicit tests. I think having an implicit test here makes it so that people that just come in don't understand what they're doing, because this is actually a test. It's just that you don't see it because there's two levels of imports that obscure that information. So that makes it a little tougher to get into. At the same time, we do need the wiring to deploy, right? We need these file for the deployment. We basically need to customize set system to customize the deployment. There's nothing you can do. You got to do it. And in order of testing, we need to set up the mini deployment, which is the fixture here on the mini deployment, which is, as you can see, it's really, really simple, or at least it looks simple, but there's a lot to that. So yeah, all in all, I think the system is actually very well thought out, and it probably will require like a video like the one I just made, but better structured to get more people to understand it fully and to take advantage of it. But given that, I guess the other side of the question, so is it written properly? Does it work? Is it good? Yes, yes, yes. So the other side of the equation is, if we're gonna spin out into having people writing one file to write one strategy, if we're gonna do that, then what do we write in the mix and what do we test? That's the big question that we're left with. And I would assume that a setup that basically deploys, tests, and so basically wires it up so you have a controller plus vault plus strategy. Then you deploy so that it's just deployed. And then it tests it, where it tests what will it need to test? It will need to test the deposit, the withdraw, which are actually called underscore deposit, underscore withdraw sum. And then it will also need to test the harvest, and it will need to test tend and is tendable, which are optional. But fundamentally, those are the things we will need to test. So those three things must be tested at the mix level. And these things will be nice to be able to test them at the mix level. Additionally, if we write the mix in such a way that it allows us to deploy this entire thing, then we could basically do the same thing that Yearn did with Ape Tax, where we can have independently deployed strategies that are running. And if you don't know what this is where you see what Yearn is doing, basically. The cool stuff is here, the really cool stuff is all here. But basically, you will basically write something similar to this, where the only person that can interact with the strategy is the deployer, so that it's secure, because you can, lose your own money, so who cares? And doing that would allow to do a private launch where you just test it internally with your own the strategist funds. Then you can do the guarded launch where you start doing integration testing, which will be the thing we just covered. This will be the integration testing. And then obviously you would have some mainnet stuff that happens after. So I don't know what the right answer is. I think I'll just slip on it. And I'll basically just start to wire this up and see what I can do. If you want to check my progress, you can go on my GitHub, github.com/gaudasballo. And you can see that, everything is open source. So you can just stalk it here. I think this one is called the Badger set mix. So check the Badger set mix as I'll be releasing it shortly. That said, thank you for watching the video. If you have any question related to Badger, I'm really studying the topic deeply. So please ask them away and I'll try to answer the best I can. Thank you very much for watching and have an amazing rest of your day.